So students, let us continue. Next that we need to study is about parallelogram. I know that you will be thinking, oh wait, we already studied about that. Yes, we did. We just have to see one more thing about it. So let us go on to that. So as before, imagine a parallelogram and imagine two. This is the names, and then so this is a parallelogram AMGP. Imagine the diagonals. There are two diagonals. So also imagine these diagonals, and what I'm going to say is we can see that this diagonal PM divides A and G into two, right? I mean this diagonal PM cuts the diagonal AG into two. That is like this. We know that. We can see that. Also diagonal AG cuts diagonal PM into two, right? That also we can see. So totally we see that we have four parts in a diagonal. This part, this part, this part, and this part. Now can I prove that these parts are equal? I mean diagonal PM cuts AG into two equal parts, and diagonal AG cuts diagonal PM into two equal parts. Can I prove that? So the cutting into two equal parts, the whole thing, that big sentence can be said in one word: bisect. So the question is, does the diagonals bisect each other? Now, what does the word bisect mean? Bisect is made up of two words, bi and sect. It is one word, but it comes from two words. And bi means to, sect means to cut. Okay, so just put them, interchange them. That means to cut into two. That's the meaning of the word bisect. But in geometry, we use the word bisect when we cut it into two equal parts. That is when we use it in geometry. Okay, so to cut into two equally. So does PM cut diagonal AG into two equal parts? That means does PM bisect AG, and does AG bisect PM? That's what we need to prove, or we need to see, or we need to check. So how to check that? Imagine these two triangles. There are four triangles now actually, but imagine these two triangles. If I can prove that these two triangles are congruent, if I can prove that, then by CPCT, that means by corresponding parts of congruent triangles, I can prove that this side will be equal to this side and this side will be equal to this side, right? But the first step is if I can prove that they are congruent. If they are not congruent, then the whole thing is waste. So let us try to prove, or let us check if they are congruent or not. So first thing, let us, this side AP is equal to MG, right? We know that because opposite sides of a parallelogram are equal. Okay, that is one thing. These two angles are equal. AP, this angle here and this angle here, both of them are equal because they're alternate interior angles. That also you know. These two angles are equal. How? Vertically opposite angles. That also you studied in the last chapter. So you have two angles and a side outside. Two angles and a side outside. So what is that? A angle, second angle, and a side outside. AAS. So by AAS rule of congruency, you can say that these two triangles are congruent. Now I will call this point O so that I can name the triangles, and let me name the triangles. Triangle AOP, that means this triangle is congruent to triangle how do I name this? There are, I can use any of these names. Now, which is the right naming? That's what we need to choose. Because if we name it correctly in the way in the corresponding order of A or P, then we can take CPCT very easily. So how to name it? So let us check. Now OGM is not possible because it is A or P. We know that O comes in the center. O is the middle, the middle vertex. So it is not possible. OGM will not work. It is not at all in the order. So we'll take OGM out. Then angle AOP. Let us look what angle AOP is. Angle AOP is this angle, and this angle is equal to angle MOG. MOG. Okay. But I could also call it angle GOM. Okay, so that also makes it a problem. Okay, so let us keep that anyways. Then angle APO, this angle that we took, is equal to angle GMO, right? GMO. So, so we see that A corresponds to G, and O of course corresponds to O, and P corresponds to M. Do you see that? So therefore, so because of that, I cannot take MOG because A corresponds to M here, so that is wrong. So I'll take MOG out. So this is the right way. So triangle MOG, this name I cannot use it. So that also goes. So this is the right way of writing triangle GOM. So triangle AOP is congruent to triangle GOM. We have proved that. Now by CPCT, let us look at the corresponding sides. AO is equal to GO. We can say that because these two triangles are congruent, right? So AO and GO are the triangles. So AO is equal to GO. Therefore AO is equal to GO by CPCT. Should write that in the bracket because we should say how we got it. And then OP, another corresponding part, is equal to OM. Or we can say PO is equal to MO. Just writing in the back reverse order. When you are reversing this also need to be reversed. PO is equal to MO by again CPCT. That means this side is equal to this side. So by CPCT we could prove that the diagonals of a parallelogram bisect each other. Okay, so that's all for this video.